Hello everyone, I am Dr. Sirajul Faisi. I welcome you in my YouTube channel. Today in this video, I am going to discuss about factors affecting reactivity in substitution reactions. You know, four important factors. First, factors, nature of attacking groups. Second, nature of alkyl groups, means substrates. Next important point, nature of living groups. And the last important point, nature of solvents. So, my friends, I will discuss step by step, one by one, each factor so that it is clear to you factor affecting the reactivity in substitution reaction. So you know about the hydrolysis of methyl bromide, which takes place by SN2 mechanism. You also know tert-butyl bromide hydrolyzed by SN1 mechanisms. These two things is already clear to you. Means you know about the SN1 and SN2. SN2 reactions always before methyl bromide or 1 degree and SN1 mechanism before tert-butyl bromide and 3 degree. Other alkyl halides undergo hydrolysis by either mechanism depending on their structures and experimental conditions employed. You know, two mechanisms apply in a given reaction of a particular reactants. How can we predict which two mechanisms apply in a reaction of a particular reactants? It has been found that at least four factors influence the relative reactivity of aliphatic compound in substitution reactions. So, structure of alkyl groups. In SN2 reactions, my friend, the order of reactivity of various alkyl halide follows the sequence, means primary, secondary, and tertiary, and methyl halides. This is sequence of SN2 mechanism. You also know the electron withdrawing or electron releasing by substituents does not affect the rate of the SN2 reactions. However, it is influenced by a steric hindrance around the carbon site undergoing displacement, since the nucleophile has to push in among the 3 carbon substituent to reach the transition state, which is the characteristic properties of SN2. You know, as hydrogen atoms are replaced by the larger alkyl groups, nucleophile find it increasingly difficult to approach the carbon site. Also, if the substituents are bulky, the transition state would be heavily crowded, and the non-bonding interactions between various substituents would raise its energy. While considering the SN2 reactions of alkyl bromide with iodide ion, it was observed that if we presume the relative rate of displacement of bromide to be 1 for ethyl bromide, it is 150 for methyl bromide and 0.008 and 0.001 respectively for isopropyl bromide and tert-butyl bromide. This is the sequence. So, see the simple equations or reactions. RBr plus I minus, it gives Ri plus Br minus. The relative rate of displacement for bromide ion is in neopentyl bromide, this bromide has been found to be 0.00001, and this last example, neopentyl bromide is a primary alkyl halide, but even then it is very unreactive in SN2 reactions because of steric hindrance in the transition state by methyl groups on the beta carbon. Now friend, in contrast to SN2 reaction, the sequence of reactivity of alkyl halides has the following order in SN1 reaction, means tertiary greater than secondary, secondary greater than primary, and primary greater than methyl halide. So, the sequence is so pronounced that it is most impossible to avoid SN1 reactions with tertiary halide. Now friends, you know carbocations are intermediates in SN1 reaction, and therefore the factor favoring the formation and stability of this ion would increase the reactivity in SN1 reaction. The alkyl groups are electrode releasing, and so when attached to a carbocation, they tend to release electron to that carbon and thus reduce the positive charge by acquiring a little positive charge themselves. Because of the dispersal of the charge, carbocation tend to become more stable. Thus, carbocation stability runs in the same order as alkyl halide reactivity in SN1 reaction. So, the order of stability of this carbocation is also explained by hyperconjugative effects. My friends, interesting examples of the effect of structure on reactivity are provided by compounds with potential leaving groups at the bridgehead carbon. That is very important term, bridgehead. So, 1-chloroapocampane does something like not hydrolyze upon being in reflux with alcoholic potassium hydroxide for 24 hours. The low SN2 reactivity of 56, this compound, is attributed to the fact that the nucleophile cannot approach from the rear. Moreover, the bridgehead, this is the position of bridgehead, this is the position of bridgehead. Carbon atom cannot assume copolarity because this is on the bridge, so copolarity is difficult here. So, because of the steric requirement of the bridge ring structure, ionization leading to the formations of a carbocation is also prevented. Similar arguments explain the failure to replace the bromine in 1-bromo-tryptosine, this 57, this compound. So, what is the other reasons? Other reasons, steric accelerations. Another factor that favored SN1 substitution is steric. If the alkyl groups attached to the carbon undergoing substitution are large, they facilitate the attainment of the copolarity of the carbocation because in the process the bond angle is necessarily increased from 109.5 degree to 120 degree, and thereby reducing the non-bonded interactions among the alkyl groups. As a consequence of this structural feature, primary halides mostly react by the SN2 mechanism, and the tertiary halide mostly by SN1 mechanism. Secondary halides may react by either, depending upon the conditions of the reaction, notably the solvent and nucleophile. Now, the important another factor, effect of unsaturation at alpha-beta carbon. Now, vinylic halides and aryl halides do not undergo SN1 or SN2 reactions. There are two reasons for the failure of SN1 reaction with these substrate. First, vinylic and arylic cation are very unstable. In fact, more unstable than primary carbocation because the positive charge is located on an sp2 hybridized carbon, which is very resistant to becoming positive charge. So, second sp2 carbon forms much stronger bond with the halogens, and it is very hard to break the carbon halogen bond. Look at here. You can see this CBr bond very strong, very strong. So it is not forming vinylic cation, very unstable. On the other hand, similarly, this carbon and C, this bond. So it is also very difficult to form this. Now, these compounds do not undergo SN2 reactions because when the nucleophile approaches the backside of sp2 carbon, it is repelled by the pi electrons cloud of the double bond. Now friends, I will show you here. You can see this center. No possibility of attacking of nucleophile. So this position also not possible. So allylic and benzylic allylic and benzylic halide readily undergo SN1 reactions because of the easy of formation of resonance stabilized carbocation. So look at here, this bond will break very easily, leaving groups Br minus leave the center and forming resonance stabilized carbocation, and this is the product. On the other hand, you can see here CH2Cl, this bond will break and form this resonance stabilized carbocation and further reaction with methanol forming the ether. So when two different groups are bonded to sp2 carbon of allylic halide, two products are obtained. You can see formation of this carbocation, so this product is possible. This carbocation is resonance stabilized, so carbocation shift on this carbon, so product is this. So in summary, we can say that methyl iodide and primary alkyl halide undergo only SN2 reaction, as an SN1 reaction involves the intermediacy of the higher unstable carbocation. So tertiary alkyl halide, on the other hand, undergo only SN1 reaction because of easy of formations of stable carbocation, and also due to steric hindrance, making them unreactive in the SN2 reaction. Secondary alkyl halides as well as benzylic and allylic halide undergo both SN2 SN1 reaction due to relatively less steric hindrance and formation of relatively stable carbocation. So vinylic and aryl halide do not undergo SN2 or SN1 reaction. In our next video, I will discuss about nature of solvents. What is the importance role of solvent in SN2 and SN1 reaction? So friends, if you like this type of video, then subscribe my channel, and thanks for watching.